everybody to my next video. This is the Apple I. The Apple I was designed by Steve Wozniak and introduced on 1st April 1976. It was the first home computer affordable to everybody with a price of only $666. It ran at a speed of around 1 megahertz. And this was the first product of Apple when the company actually was founded. In this video I will give you a short user experience, what it would have been if you bought this computer and used it on your first day in 1976. If you bought this machine, you would have got such a user manual. And in this user manual, on the first page, you could see the specifications. So here, the specifications. It is actually built for NTSC video, as typical in USA. It ran at the frequency of 0.96 MHz effectively without refreshing the DRAM, so taking the time out for refreshing the DRAM. The line rate was around 16 kHz, frame rate 60 Hz, and the display memory was built by shift registers. So I will do an additional video where I will show you how the circuitry actually works. So then you get these small examples. For example, how signals from keyboard reach the main board, and you get examples. We will go through these examples. You would actually start after building your own PC with this main board. You had to attach a keyboard, you had to attach your own power supply and your own monitor, and then you would usually start with these instructions to test the machine. On this page you can see a listing of the actual monitor program. The monitor program was developed by Steve Wozniak and is an ingenious piece of software because it fitted in around 253 bytes. And the display driver, for example, has only one line in assembler. Yeah, and in the end you get schematics for the actual microcomputer and for the this is the video. Yes, this is the video circuitry, and this is the main board, the PC circuitry. So one ingenious idea of this PC was that in the upper part, in the upper two rows of ICs, you have a complete video section. This means you can just plug any household TV, and then you would see a teletype, like a teletype screen, where you could enter your machine program with hex codes by keyboard. And this was vastly superior to the input of programs by dip switches.
07127, deposit 121, 121, deposit 060, deposit 306.
Yeah, and in the lower two rows you see the actual PC. So here you have the 6502 CPU. The RAM, you could expand the RAM, so now we have installed 4 kilobytes of RAM. You could install another row and would get 8 kilobytes of RAM. In the very corner you have an expansion slot, and there was only one known expansion card, namely for storing program data onto a cassette tape with a household cassette recorder and player. Because RAM here was volatile, of course, and when you shut down the machine, all your program was gone. So this is the monitor switch, and now we plug in the Apple One, and as you can see, when the Apple One starts, you only get blinking cursors all over the place. And what you have to do first is reset the computer. And then you have also to clear the screen. So now the computer is reset, you see the input prompt, and now we can start typing. So if you want to examine, for example, memory address for F, or let's say 3F, and return, you would get the memory contents at this location. If you want to examine a block of memory from the last location on, for example, you want to see until address 5 return, then we get the next address after 3F, what we examined before, until 5 and a nice hex output. Now if we want to enter, for example, if we want to look at the location 00 until 10, we would type 00.10 return, and we would get the hex output from 00 to 10. Now we could start entering a program. We have to use the colon. So for example, in memory location 0 we see a 0. If we want to deposit a 1 there, we would type 0 and then use a colon. This is not a colon, sorry. The colon is, so this does not. He always aborts, so the Apple One always aborts after invalid input. So it would recognize the 0, the backslash would then indicate an error. So the semicolon is evaluated as an error and their input is aborted. So 0, then colon, and then 1, and return. And this is the old memory content. And if we then type 0, you see it has correctly stored the 1 as expected. So the machine is working. Of course, from time to time it happens that you input nonsense. So for example, input this and it wouldn't be able to recognize it as any meaningful command. Yeah, in this case it crashed because I gave it the run command and no valid program was in memory. So I can reset the machine, but before you press enter and you want to abort the input, you can press escape and the input is not recognized. However, if you, for example, input an invalid memory location, for example like this, it will take the last 4 digits. So if you mistype, you can just continue typing and it will take the last 4 digits as a memory address. But of course you could also do a space and then it would, in this case it would output the 2 addresses, so you can also plot 2 different addresses. And all this functionality is stored in only 253 bytes. This is amazing. Next we will try a short demonstration program given in the Apple manual. So let's clear the screen and at address 0 we start inputting A9 if he lets me. Yes, no. 0 colon A9 0 AA 20 EF space FF space E8 space 8A space 4C space 2 space 0 and enter. And now we control the program 0.A, enter, and we confirm it is A9, 0, AA, 20, EF, FF, E8, 8A, 4C, 2 and 0. And now we can run the program. And what the program does, it outputs a continuous stream of ASCII characters on the screen. So what you see here is the original demo software on a rebuilt Apple. I hope you liked this first video about the Apple One rebuild, and I hope I see you in the next video when I do some further software tests or explain the circuit of the main board. See you!